Climate change and human activity have had devastating impacts on ecosystems around the world. Vast amounts of land have been destroyed by fire, mining, and illegal logging, leaving them unable to regenerate naturally. Other forests are now overly dense and prone to wildfire and pests. In urban and agricultural communities, hundreds of millions of tons of wood and agricultural waste are sent to landfills each year, where they decompose and release greenhouse gases. A Woodvault is a hybrid nature-based and engineered approach to carbon removal. It entails sustainably harvesting or collecting wood and storing it underground for a long duration. Biomass is isolated from the biologically active topsoil to ensure anaerobic conditions which prevent decomposition. This transfers biomass from the fast biological carbon cycle into the slow geologic carbon cycle. Woodvaults offer 1,000-year or more durable storage and low CO2 secondary emissions. It's highly scalable, offering the potential to offset all GHG emissions of the entire ag sector. To construct a Woodvault, the first step is to identify an appropriate site that has deep soils with low permeability. Then biomass must be sourced from as close to the burial location as possible in a manner that does not damage residual trees or forest soils. Next, soil is excavated to form a large trench. Then the wood is buried in the subsoil, ideally 10 feet or more below the surface. The pit is then divided into multiple sections. After each section is filled with wood, a layer of soil is added on top and compacted before more soil is added. After the vault is enclosed, grass or shrubs can grow back and the land can be reclaimed for recreation, conservation, or agriculture. Long into the future, the vault will be monitored to ensure durability. Woodvault technology is a global solution. Our submission spans 4 projects across 4 different biomes across 3 countries with 3 different sources of biomass: degraded ecosystems, agricultural waste, and urban wood waste. In Indonesia, we are reclaiming deforested mining land through burial of agricultural waste, followed by reforestation of native forest, bringing back tropical biodiversity and empowering local communities towards regenerative industries. In British Columbia, Canada, and in Montana, USA, we are restoring burned forests by replanting native species, significantly mitigating carbon emissions and reducing the risk of future wildfire by burying burned, dead biomass before it can decompose. In British Columbia, this approach will allow for the reopening of important community trails. In Montana, this will support migratory elk habitat in the greater Yellowstone ecosystem. In Maryland, USA, we are burying urban wood waste sourced from mixed hardwood forests, which are experiencing mortality in white oak and other species due to climate-driven rainfall events, creating hazards for suburban homes and infrastructure. 4 projects demonstrating how the same solution can be applied to a range of problems. Woodvaults also offers substantial co-benefits. These include removal of dead biomass that is an impediment to ecosystem restoration, leading to improved water quality and enhancement of critical wildlife habitat. Ecosystem restoration also delivers future carbon removal as newly planted forests grow and sequester more carbon. Woodvaults will also deliver rural economic development for communities historically dependent on extraction-based economies. Finally, Woodvaults reduce future risk of fire, significantly decreasing future carbon emissions. By embracing Woodvaults as a carbon removal pathway, we not only safeguard rural and urban communities and mitigate carbon emissions from wildfires and landscape degradation, but also catalyze ecosystem restoration on a global scale.